Hey guys, it is Queen Kessous here to teach you some laws of exponents. I have my little bitty skull to help me, a little Dios de los Muertos. Let's start with negative exponents. I'm going to go fast, so feel free to pause at any point if you need to. So remember that when you have a negative exponent, it becomes a fraction. And I'll give you a quick recap on why that is. Remember that if you have 3 squared, 3 to the first, 3 to the 0, okay, 3 squared is 9. 3 to the first is 3. So as I'm going this direction, I am dividing by the base number every time. So 3 divided by 3 gives me 1. 1 divided by 3 gives me 1/3. So the minute that I get into the negative exponents, it is a division problem, and it will always be a fraction. So 5 to the negative 2 power is going to be equal to 1 over 5 squared. That can be simplified to 1 over 25. Here we have the same bases, and we are multiplying. So we learned that we can add the exponents when the bases are the same. So this would be the same as negative 3 to the negative 5 plus 2. That would equal to 3 to the negative third. Again, I have a negative exponent. So that is going to become 1 over 3 to the third, or 1 over 27, because 3 times 3 times 3. So those are the same thing. Let's keep going. So now we're going to go to multiplying. When we are multiplying, the first step is you always look for coefficients. Multiply those coefficients. 2 times 7. Okay, those are super important. 2 times 7. That will give you 14. And now, if the base is the same, you add the exponent. So I'm just going to show what that looks like. The x has the 3 and the 2, so I'm adding those. The y has the 5 and the 10, so I'm adding those. Because you would have 3 x's here, 2 more here, that's 5 altogether. X to the 5th. You have 5 x's here, 10 more here, that's 15 x's or y's being multiplied. That's how you simplify when you are multiplying. Next thing we are going to do is power outside parentheses. So the first way is whatever is inside, you write it this many times because you're multiplying it that many times. So it's 4 to the 5th, and you write it 4 times. Then you use what we just learned, and you just add those exponents. So we already said if the base is the same, I can add the exponents, and that would become 4 to the 20th power. The shortcut is, if you're adding the same thing over and over, that's just like multiplying. So really, you can distribute. This is what you have to be careful of. Remember that the 5 would be written 3 times. So it would be 5 times 5 times 5, which means that when I distribute this exponent, it has to go to every single thing, including the coefficient. So everything is going to get it. So it's going to be 5 to the 3rd power. X to the 6 times 3 is 18. Y to the 2 times 3 is 6. And Z, if there's no number there, there is an invisible 1 because you have 1Z right there. So 1 times 3 would be 3. Then I could simplify 5 to the 3rd power. 5 times 5 is 25 times 5 is 125. And this would become 125, x to the 18th, y to the 6th, z to the 3rd. The last one, because this is a binomial, it has the plus sign in it, you have to write it twice. So you would write 2x plus 3 times 2x plus 3, and then you would either use box or the FOIL or distribute method. Okay, and that's how you would multiply that guy. So you cannot distribute if there is a plus sign inside. Moving on to dividing monomials. You should be pausing everywhere and taking notes, so if you need to go back, go for it. So the next one, just like multiplying, we start with the coefficients. Here I'm dividing them, but I want to really just think about simplifying. So what number goes into 16 and also into 24? I can divide those both by 8. Divide by 8. So 16 divided by 8 is 2, and 24 divided by 8 is 3. Now I want to think about the exponent. So you would have 7 x's on top, 6 on the bottom. So 6 of them would cancel, right? Leaving you with just 1 x on top. Really what you're doing is subtracting the exponents. So the shortcut is when the base is the same, you subtract those exponents. And so this would be 7 minus 1, 9 minus 6 is 1. So you have x to the first or just x left on top. If there's no number there, you put a 1 in. You have 2 y's on top, 1 on the bottom. 1 would cancel, leaving you with 1 y on top. Okay? 2 minus 1 is 1. Let's do another one, similar. I'm going to just slide it over here. So there's no coefficient in front on the bottom for me to simplify with. So really, I just bring down the 8 on top. Now I look at the x's, and it's x squared on top, x to the 7th. If I subtract that, I would get x to the negative 5th. But we learned what happens when you have a negative exponent. It goes to the bottom of a fraction. Okay, and the 8 would stay on top. Y to the first minus 6, 1 minus 6 is negative 5. So it would be y to the 5th, because that would have a negative exponent as well. So when you have a negative exponent, it's going to move to the bottom of the fraction. Okay, it's going to move to the other side of the fraction. Because x to the negative 5th is the same as 1 over x to the 5th power. Okay. So that's a really important thing, is that if you're subtracting and you get a negative. Another way to think about it, if you had 2 x's on top and 7 on the bottom, when they cancel out, where are the x's that are left? There was more here, so they'd be on the bottom. That makes sense. Okay. Last section is mixed operations. So let's take a look at these. We're going to do each one separately because these are using all the different things that we've learned together. So in my first one here, I want to look to see if I have coefficients. I don't. Do I have any parentheses with an exponent outside? I don't. So I want to simplify the group that is the top. So I'm going to simplify this first together, and I'm going to simplify this together because that can be simplified. So what I'm going to do now is these are being multiplied, so I'm going to add the exponents. So it's really like y to the negative 1 plus negative 5th, and that leaves me with y to the negative 6. Okay. Negative exponent, what's going to happen there? It's going to go to the bottom, 1 over that. Let's simplify the x's really quickly. Again, this is multiplication because they're touching, so I add. So it's really just 8 plus negative 2. That gives me x to the 6th power. I don't have to change anything because I didn't have a negative exponent. Because this one was a negative, it's going to have to go to the bottom. So it becomes 1 over x to the 6th, y to the 6th. Order does not matter. Okay, let's look at the next one here. In the next example, we do have a number outside the parentheses. So I want to look at that guy, okay? And I want to simplify that first. So a number outside parentheses, because that's exponent, and you think about PEMDAS, right? Exponent comes before multiply. Only goes to what's inside parentheses. So it only goes to that. So this stays the same. Everything else stays the same. Over negative 3. And then it becomes r to the negative 10th power because you're multiplying when it's power to a power. Now I'm going to simplify. So there's nothing else I can combine on top, nothing I can combine on bottom. I simplify the coefficients. I can divide these both by 3, okay, and I end up with negative 1. And these have the same base, so I'm really just subtracting. So it's negative 7 minus negative 10. What happens when we have minus a negative? Becomes plus. So this becomes r to the 3rd power. Because it's a positive, it's going to stay on top. And that's our answer. So it would just be negative 1 r to the 3rd power. We don't have to write the division line anymore because nothing's on the bottom. Last one we're going to do right here. We do have an exponent outside parentheses. I always look at that guy first. So exponent outside parentheses, that's where I'm going to start. It's going to get distributed to everything, the coefficient included. So this becomes 3 to the negative third, t to the positive third. Bring everything else down. 7 and j. Nothing can be simplified in the top or in the bottom. But this negative exponent tells me that it's going to have to become a fraction. So it becomes t to the third, 3 to the third. Notice that when it becomes a fraction, it's not negative anymore. Times 4, t to the 7th, and j. That is the ugliest j I've ever made. Okay. Last thing we want to simplify now is we have t's, and I know this is a lot, so pause it, take your time, make sense of it. Okay, the same base has an exponent. I subtract because I'm dividing, so 3 minus 7 is negative 4, meaning it's going to go to the bottom of the fraction. So I put the 1. 3 to the third is 27, and 27 times 4 is 108. So that would be 108 t to the 4th power j. Where did t to the 4th power come from? 3 minus 7 is t to the negative 4. Negative means it has to go to the bottom of the fraction. So a lot of the same skills that you're going to be repeating and practicing, that's what you're going to work on. Have fun, take notes on this, and good luck!